Hi there. This is Walter Riviera, work as AI Technical Solution Specialist covering EMEA for Intel. In this session, I would like to talk about AI and the data evolution that we're living and share with you why I do believe that this is the perfect time when technology is suggesting us to go together. So let's get started. First thing first, let's have a high-level overview about an AI pipeline structure. We would have a model and a data set, and we would train the model on one infrastructure to solve some tasks. Now, the question is, how can we eventually keep the model up to date over time or just make it more robust? From a data science perspective, an easy answer could be you just add more data, and that could work. But is it actually always possible to do this? Let me give you more details. We live in a world with a lot of shared infrastructure and distributed all over the places. It could be different entities like different research institutions, different companies, as well as different hubs or labs belonging to the same brand. Think about Intel and all the offices we have all over the places. Well, what happens if the data set that we would like to access to improve and enhance the performances of our model are dislocated and placed in different regions or in different hubs? In that case, how would you practically enhance your AI model? Would you clone and copy all the data set in one gigantic location just to have a unified hub where to train your data on, your model on? I don't think that's really doable. Think about in a very practical example in a healthcare environment. If all the hospitals in the world wanted to collaborate to build an AI model able to detect COVID-19 disease out of radiographies, I'm pretty sure each one of those hospitals could contribute with its own version of the data set. But how could you merge them together? And actually, even though somehow you would manage to put all the data set in one gigantic location, who would be responsible for that? This leads us to the other important key aspect when it comes to data access. It's about the regulations in places in the different regions of the world. GDPR in the European Union is a great example. POPIA in South Africa, it's another great example. Data is basically gaining more and more importance up to the point where it's shifting the decision-making process. It's not just about having one supercomputer unified to go fast. It's the capability to go far and go and reach beyond what is currently possible. And this is where you see the connection I did with my introduction. Why do you think technology is actually suggesting us that is the time to get together? Because we need to go beyond. Having access to external data set might actually be the key to build the next generation of AI models. What I'm talking about in practical terms, it's about a new paradigm called federated learning. If you think about machine learning, which is being deployed pretty much everywhere, AI needs data. And data, as I said, might not be always accessible in one location. At the same level, there is a new key trend rising in its importance, which is the privacy and security as key consideration for each organization, not only on the data set. Federated learning can help. How? Well, let's take a closer look at this. We used to move data into one supercomputer to compute. So the priority used to be the compute. And we would move all the data to get the power and their resources out of a gigantic infrastructure. Federated learning basically flips this approach by giving more importance to what is currently rising in terms of respect, which is the data. So we're not moving anymore the data over to compute. We're actually doing the opposite. We're bringing the compute to respect the data location. With me. Now let's get closer again into how this paradigm works. Think about the example we mentioned before about all the hospitals willing to collaborate on a COVID-19 AI model. We would have hospital A, B, and C, each one of them owning their own data set. To get a federated learning paradigm in place, we would expect to see a unified place, let's say the aggregator, which could be one node hosted in one of these three hospitals or an external party. And then each institution, A, B, and C, providing its own local computing capability plus their own local data sets. At the beginning of the federation, the three hubs would share their data scientists' brains to work on a unified model. Model can be found in literature or just can be created from scratch. Once the model is defined and it's one and unique for all the federation, that's where the real federated learning starts. The parameter server or aggregator would basically clone over all the institutions the same model. Each institution's A, B, and C would then start to train that model on their local data set for a certain amount of iterations. When that amount is reached, they would share their trained model back to the aggregator. As the name suggests, the aggregator would fuse the three or N model together and would restart the same process. What's important here is that the data set belonging to each single institution would never leave that institution. So we can be respectful of the privacy in place and the regulations in place in that region. So the data will not get shared. What gets shared among the federation and the institutions is just what the model has trained. Isn't that amazing? So if you are wondering of why you should care about this, well, there are many reasons on that. First of all is the opportunity. And when I talk about opportunity, I'm not referring only to the business opportunity, which somebody estimated to grow from 1.41 billion into US dollars in 2017 up to 8 billion US dollar in 2022. Not talking only about that. I'm talking about the opportunity to build the next generation of AI models by reaching data sets which can improve and enhance those models. We can reach accuracy level that we probably never reached before. And we can build new capabilities just because we have more juice, more information to add to those intelligent models. So far, federated learning has been adopted for data privacy and communication efficiency, but those are not the only two aspects. There is also the type of data being used. So far, it's mainly been focused on images, at least for the 50%, but federated learning can go well beyond it. Picture this example. Now, think of a market segment. It could be healthcare with the federated learning born. It could be financial institutions because banks are famous to have different hubs belonging to the same brand distributed all over the place with local data sets. Think about retail. Think about telecommunication companies. Think about energy. I mean, you name it. but pretty much everyone can fall within the bucket of a company or research institutions willing to collaborate with other entities, either belonging to the same name or under the same umbrella, or belonging to different side of the market or the world. So this is the reach, this is the actual capability of federated learning. So let's consolidate a little bit. Federated learning is ideal to solve the data access problem, but it doesn't necessarily protect the data, nor protect the model, nor protect the training process. So one might argue, hey, Walter, this is interesting. I can see the opportunity, the business one, but also beyond that, the scientific one. But if the whole point is to solve the data access problem and being respectful of the privacy law in places, how should we deal with the other aspects, right? That's a very important point, because when we talk about federated learning, because of the way it is designed, actually the risk of exposure can be amplified. If we think about a malicious attack, the people beyond it might not be interested only in breaking into all the institutions. They would just need to break into one institution A, B, or C, just one. If they would poison the model in that institution, that can easily propagate over the whole federation, corrupting and compromising the training for the entire hubs involved. So what does it take to secure FL, right? Because so far we've been saying, what is the challenge that it helps to address? What could be the challenges that comes when we adopt federated learning, but what does it take? Well, we basically summarize the three aspects, which is we would need to improve confidentiality. We would need, which is basically the capability of protecting data and models from untrusted external parties. We would need to take care of the execution integrity. It's not just about protecting data while they're sitting in the data lake. It's also the capability to protect the data while they are being used to train a model, so at execution time. And ultimately, the attestation. So the capability of validating that the software and the hardware being used during the federated learning by the institutions belonging to the federation are genuine. Here's a very easy answer to start address all those bullets, and that answer is Intel Software Guard Extension, or well known also as Intel SGX. SGX is basically a set of instructions that can be used by application to get aside private regions of code and data within the CPU. So you can think of it as a kind of protected area called the enclave on the CPU, which is completely encrypted and to protect processing execution at runtime. You can think of running your application on bare metal or in a container or virtual machine, whatever. As long as you execute it within the enclave, that execution stays protected with a very sophisticated encryption key. That encryption keys belongs to the hardware and the software of that specific machine. You can think of it as a kind of unique ID belonging to that machine to help you protect whatever is being executed on it. Sounded cool, isn't it? Back to our federated learning setup, how can SGX help us out? Well, if you think of having a federation where either the aggregator or parameter servers and all the collaborators can benefit from SGX, you can basically be sure that you've added a lot of security layers. Obviously, security is never enough when it comes especially to technology, but this is a very great ally to have and rely on. So the pipeline would look like this. We would be able to secure the execution. And if you're wondering how we could secure the A, B, and C, the data set locally available in each institutions, well, for that, there is a rich literature in the world and about how to encrypt data that are residing into a data lake. But SGX is extremely powerful to protect the execution and protect the data and their integrity while we're using those data to train the model. Let me give you a quick representation of what we discussed so far and how federated learning would work with SGX. So in this slide, this animated slide, we have basically two hubs. One is just the collaborator. So this institution is a collaborator. This institution is also hosting the aggregator element. You can think of these two as like single nodes or just a representation of what could be a big HPC infrastructure. Concept is still there. Excuse me. So each institution, each collaborator would basically access their local data set. Would use that data set to train the model, and then they would encrypt everything within the SGX and ship the encrypted version over to the aggregator. The aggregator, as the name suggests, would merge together the model and then send back the fused version. The result of this is that over time, the global model validation would increase. This is how it works. Okay, now you may think about, okay, I got the concept, I got which things are important and I should be taking care of, such as security and privacy. How can we practically do that? I know that Intel SGX on board of the third generation of Xeon Scalable family, the latest, can be a great ally to increase my security, the security of the infrastructure. But how can I practically implement a federated learning approach? How can I practically bring to life a federation with different institutions? We've been developing an open and free tool called Openfl, now available in the version 1.1, very close to 1.2, so stay up to date. The GitHub repository is already publicly available and accessible. It's very easy. It comes also with scripts to help you out instantiating a federation with just one command and see the whole process happening. And it also allows you to create a proper federation at deployment level or production level by distributing the code across multiple nodes. So that's already a feature available in the Openfl. It allows the software developers and researchers and all the users passionate about this, or they are willing to take a step further into federated learning, to import their code written in PyTorch, TensorFlow, more generically speaking, in Keras. And once you uploaded your model and you plugged in your data, you're pretty much good to go. There are already a lot of examples, either for client command line interface, so the CLI for the passionate about the shell, as well as Jupyter Notebook to help people get going with Openfl. So as I said, it's already publicly available and it's already there. If you're wondering whether we should expect to see this federated learning at work in real life, well, I have great news. This is already happening. One of the greatest results I would like to share with you today talks about the collaboration between Intel and the University of Pennsylvania. The medicinal school, the School of Medicine and the University of Pennsylvania. There is a paper that we published demonstrating that the convergence of the model. So pretty much showing that if you have one gigantic infrastructure hosting all data where you train your model on, or you adopt a federated learning environment approach, pretty much you can get to the same result, demonstrating that federated learning can actually be effective to solve the challenges, the data access problem that we mentioned before. As a direct consequence of this collaboration, we now have a new collaboration that we're working on involving 29 healthcare institutions around the world to build a joint AI model leveraging that massive data set. Super exciting project ahead. So there are also other collaboration in the finance landscape, but hey, as I said, you name it, okay? The capability of federated learning and Intel SGX goes well beyond what has just been done. It's really about help evolving the market and the environment all together. So with that said, I would like to close this presentation with the words of our co-founder, the co-founder of Intel, Robert Noyce. Don't be encumbered by history, go off and do something wonderful. I think this is the right time where we see this capability of going beyond and reach out to others. So again, we are here, Intel is here with Openfl, with SGX, with many other solutions in our portfolio, either software or hardware, and with all the right bits and pieces for AI. And so our purpose is definitely to go further and to go far together with you. So thanks for watching, and I'll make sure to stay around in the lounge for later on. So if you have any further Q&A or you would like to have a chat, let's meet there. Thank you very much.